Hi, my name is Matt. I'm a developer on the team for the Tilvus Assistive Interface. Our software is controlled using a switch, usually a single switch. Could be a button, which we've shown in other videos, could be an eyebrow switch or a head switch or a sit-puff device. But today I'm going to be using a brain-computer interface, a BCI switch. And this enables me to select buttons and submenus in the software using thought. And this headset enables me to do that.
Hi, my name is Tony Q. I'm also a developer with Tilvus. I'm going to be narrating the demo today and basically telling you what Matt's going to be doing, because Matt's going to be purely using thought to send key clicks, think click if you will, to select different options within the system. He's selected the clicks to go into PhraseWeaver Predictive keyboard. This is a keyboard where there's multiple letters on each key. So what he's going to do today is he's going to try and type the phrase, "The quick brown fox jumps over the lazy dogs." So he's going to start with the key FLTU that includes the letter T, and you're going to see that we then come up with predictions, which are five words as part of the phrase, and he's going to select the one that starts with the word the quick brown fox. Now you're going to see that with the actual phrases, it cycles through 1, 2, 3, 4, 5. How many of these words do you want? You're going to find that Matt's going to be cycling through all our menus a lot because of the way this interface works. It's very difficult to make a click and then a click immediately afterwards, so you kind of have to cycle through the menus. The interface is actually using this by a company called Emotiv Systems. It's an Emotiv EPOC Neuroheadset, and it works in several modes. And we've got this working in the cognitive mode. The cognitive mode means it's purely thought-based. You're thinking about a click, and that's been interpreted as a click. It's been sent, in this case, as if it was like a mouse click. And that's one of the kind of click-type devices that we can use in this environment. And so he's thinking these clicks out. At the moment, he's typing QUI to get quick, and you'll see that one of the sentences, the predictive phrases, starts with the word quick, so it's going to select that and select the word quick. The EPOC device also supports expressive mode. That is to say, if you smile, raise an eyebrow, do something physical, it can interpret the brainwaves for that. And in that mode, it tends to be more accurate. But we wanted to show today that you can do it without the ability to even think the thoughts that are associated with moving your eyes. If you're severely disabled and you've not been able to, you don't even have any face motion, let's say. Just purely by thinking click, you can actually use this device. So Matt has entered a B. He's going to pick up brown fox jumps over the, and then eventually he's going to cycle around and get lazy dogs. Now in this case, what we're going to do is we're going to actually use the option to speak an input, but you can also take this text and use it as text input to any program that runs on Microsoft Windows, Microsoft Word, a text editor, or anything you like. So, as I say, in this case, he's going to select lazy dog, this sentence. There you go. And then he's going to go into the menu associated with speech, and you'll see it cycle through, and then when you click the button, it's going to speak that sentence.
The quick brown fox jumps over the lazy dog.
And there you go. As well as text entry, we have a couple of ways of doing emulating a mouse in a mouse type environment. And so in this case, we're going to show you the BMI device with the coaster cursor. So the way the coaster cursor works, it goes around quickly, and then you'll think of a click, and then it'll start to go more slowly. That just gives you the ability to get around the screen a lot faster. Then he's going to think of a click again to head off in the direction towards the icon. Now, we're a little low for that icon, so when he thinks of a click and it stops, he's then going to use the nudge feature to nudge that over onto the icon that he wants to select. So again, every time he's just thinking of a click, nudging in a given direction. So he's going to go over, he's going to go up a little bit, so it'll take a little bit, but the point is you can do this, you can get there from here, and this has all been done by thought. Now, we do support, as I mentioned at the start, many types of devices. As the input interface sit path many kinds of buttons, buttons that generate a mouse click, buttons that generate send the equivalent of a keyboard, head switches, eyebrow switches. So we can support all those kind of devices. And in this case, this is interesting because this is unique in that if you can't even physically click something, you can still use this device.
Yeah, and that just about wraps up our demonstration, I think. I made a couple of mistakes along the way, obviously. It's not an exact science. I've only had this for less than a week, maybe 6 or 8 hours I've spent practicing with it. But with more practice, you can definitely get very accurate with it. And for people who have locked-in syndrome, who can't move at all, if this is their only way to use a computer or their only way to enter text, it's certainly better than the alternative, which is nothing. So it really can help a lot of people. You can go to tilvus.net for more information about the software, also to see more videos that demonstrate some specific features of the software and describe how the software works in more detail. But thank you for watching.
Thank you, indeed.